Today, let's look at solubility equilibrium and more specifically, the common ion effect. So many students usually struggle with this part. Now, let's look at what is the common ion effect. For a sparingly soluble salt like BaSO4, in water, it will be sparingly soluble. It will dissolve partially to give you Ba2 plus and SO4 2 minus ions. Okay, so there will be a bit of a solvation. Now, if there is either Ba2 plus or sulfate from another source, this will affect this original dissolving equilibrium. Okay, so example, if let's say you add in BaOH2, which is a strong base, it will fully dissociate to give you Ba2 plus and OH minus. So now you have excess Ba2 plus over here. So therefore, there's excess Ba2 plus, this equilibrium will shift left, which means this Ba2 plus here is known as your common ion. So this common ion effect here will decrease your solubility of your original BaSO4 salt. Okay, so this is why over here we say that the common ion effect will decrease the solubility of your sparingly soluble salt. So let's look at it quantitatively. What does it mean? Okay, so first of all, let's look at the solubility of BaSO4 in water, which means at the start, it will dissolve a bit to give you Ba2 plus and SO4 2 minus. Okay, so if you do an ice table, solid will be a dash. This will be 0, 0 at the start. And it will dissolve a bit to give you Ba2 plus and sulfate. So this is governed by something called KSP, which is equals to Ba2 plus times SO4 2 minus, which is equals to x squared. So this is 10 to the power minus 10 equals to x squared. X will be equals to 10 to the power minus 5 mole per dm cube. Okay, so this will be your solubility. Whatever dissolved here will be your solubility. So the X is always the solubility. So this is without the common ion effect. On its own, how much of it dissolves. Next, let's look at what happens when you have a common ion effect. You will notice that the amount that is soluble will decrease. Okay, it will go down, it will decrease. So let's redo the ice table. I'm just going to copy and paste. And paste it here. Okay, now what is the difference? Because of the common ion effect, your Na2SO4 will dissociate fully to give you Na plus and SO4 2 minus. So therefore, there's an additional source of sulfate, which is 0.1, which means at the start, this sulfate here is no longer 0, instead is 0.1. Okay, so this at the start will be 0 plus y plus y. So KSP will be equals to y times 0.1 plus y. And because y is small, so 0.1 plus y will be approximately equals to 0.1. So if you solve for this, KSP is 10 to the power minus 10. Y will be 10 to the power minus 9 moles per dm cube. Okay, so this is the new solubility of your of your BaSO4 with the common ion effect. So you can see that it is much less soluble compared to just now. Okay, so just now the solubility of BaSO4 is 10 to the power minus 5. Now the solubility is 10 to the power minus 9 mole per dm cube. Okay, so it's a lot less soluble due to the common ion effect. So once again, this is 1 minute of chemistry. I'll see you the next time.